how to use the summation notation. Basically, for example, we wanted to add, let's say, numbers like 2 plus 1 plus 6 and then plus 4. Now, these are only 4 and you may not need any notation to do so, but eventually what we wanted to do is somehow come up with a way to write down these terms in a compact and nicer way. So what we'll do is first we'll use I as an index, as a placeholder. So I for this one will be the first term, right? And then the second term, right? The third term and the fourth term, right? And then we could use x, y, z, and the most common is x sub I. So x sub I will be those values. So so x sub I. So when it's x sub 1, it's 2, right? So x sub 1 is 2, x sub 2 is 1, x sub 3 is 6, x sub 4 is 4, right? So now what we have is we created an indexed value where we'll be able to have a placeholder to do this work. So this can be now done, this Greek letter, uppercase Greek letter sigma, now where the index I is going to run from 1 to, now we have how many terms? 1, 2, 3, 4. So this is the end. The last term is the fourth one, the first term is 1. And now instead of writing this values 2, 1, 6, 4, we can write the indexed variable x sub I. So x sub I now, where I runs from 1 to 4, well, we can rewrite this as x sub 1, okay, plus x sub 2 plus x sub 3, and then the last one, so remember this I goes up to 4, so we stop at x sub 4. Now the values here of the unknown variable here x are 2, 1, 6, 4. So once you substitute 2, 1, 6, 4, this function right here, or this notation right here, gives you the sum of the first term, the first 4 terms, first, second, third, and fourth, now being held as x sub I. Let's look now at another example where now our data or the values could be the same way, but now we'll let it run up to n. So if we have a notation that says sigma, and this is the indexed variable xi, where the initial I is usually 1, but it doesn't really need to be 1. You can start at 2 or 3, but 1 is what we need for our purpose here. I from 1 up to some fixed number n. So then this one would be the first plus the second plus the third all the way up to the last term, which in this case, because the last term, even though it's a fixed number, we don't know what it is, but we'll keep doing it until x sub n, right? So now the first case, it was x up to 4, and the 4 numbers were 2, so the sum of 2, 1, 6, 4, which is 13, would have been the answer to this notation right there. This may be enough for now, but we'll try to look at another option in a little bit.